Welcome to Scaling Up, the Industrial Water Treaters podcast. Hello, Scaling Up Nation. Trace Blackmore here, the host for Scaling Up H2O. And Nation, how cool was it? Last week, the entire week was a holiday just for us water treaters. It was Industrial Water Week. And we had a day that we were celebrating a different part of industrial water treatment. We started off with pre-treatment on Monday, boilers on Tuesday, cooling on Wednesday, wastewater on Thursday, and then we wrapped it up with careers on Friday. And of course, you know, we helped you celebrate with a brand new episode each and every day of Industrial Water Week. And it was so cool to go to the Association of Water Technologies convention in Palm Springs and ask people how they were going to be celebrating Industrial Water Week. Last year when I did that, nobody knew what Industrial Water Week was. This year, it's starting to catch on, and companies are actually doing something with their people to celebrate. We did that here. We made sure that we made the most out of the holiday that was built for us, and we just had a great time with it. So folks, if you did not take advantage of that, please do so next year. It's always the first full week of October. That means next year it is going to be October 5th, 2020. Can you believe we're almost in 2020? I feel like I just did an end of the year episode for 2018 and a goal setting episode for the beginning of 2019. And now we're talking about the year wrapping up. Well, folks, we are in the last quarter of 2019. So I hope that you are like me and you took the beginning of last year to set some goals, and we talked about how to do that in the beginning of the year on that episode. And for those of you that have not listened to that episode, that was episode 67, the first one that came out in 2019. On that episode, I spoke about how I evaluate the previous year and what I do to start setting some goals for this upcoming year. Hopefully, you've been tracking along with your own goals, but like I said, we are in the third quarter. This year is wrapping up. So if you have not made some goals for yourself, it's my hope that you look at some items that you want to get completed and you figure out how you can do some of those items in this last quarter. Once you come off of that quarter with a high note, you can begin the next year with that momentum. So I hope you are going to do this. It seems like just about every single episode, I am pleading to the Scaling Up Nation to please help me find information about what to talk about. Now, I have a list and I have plenty of items on my list, but I know if those do not get replenished, I am going to run out. And when I run out, I don't have a show anymore, and I love bringing this show to you. So I am always pleading with you, the Scaling Up Nation, to send me ideas and ask me questions that you want to hear answered on this show. And the way you leave me a voicemail is you go to scalinguph2o.com, and on the right side of the screen, there is an orange button that pops up and it says leave voicemail. You click that, and right on your phone or your computer, if you've got a microphone on it, you can record a voicemail that comes directly to me, and I then play your own voice asking the question right here on Scaling Up H2O. Well, I want to thank the Scaling Up Nation because many of you have done that. I have reached out and given you a Scaling Up H2O t-shirt. I saw a couple people wearing them at the Association of Water Technologies convention. That is so cool. By the way, I always give out buttons at these functions. So if it's a technical training or a convention with AWT, I have these little 1.25-inch buttons that people put on their lanyards, and so many people kept them from previous sessions, and they were wearing 2 or 3 of them. They were proud to be part of the Scaling Up Nation. And folks, I am proud that we have a Scaling Up Nation. I say so many times that water treatment is a lonely field. Well, because we go to events that associations have, because we are all listening to the same podcast and we're all contributing to that, we are part of a community. We're all learning together, and we don't have to be alone anymore. And I don't know about you, but it just makes me feel good to know that there's somebody else out there that are having the same issues that I'm having. So by all means, please keep those questions coming, because that is making this podcast work. Now, one of the people that did that very thing, his name is Genipat, and I met him about 2 years ago at an AWT technical training event, and it was right before he took his Certified Water Technologist examination. Well, here's Pat asking his question.
Trace, this is Genipat Yoswatana over in California. We've met at the AWT training seminar, and I want to thank you for helping me pass the CWT test as well. I had a question for you. What's the difference between feeding based on percent time, bleed and feed, water meter, using a fluorescent tracer, and what are the advantages and disadvantages of each? And in what situations would it be appropriate to choose whether to use a bleed and feed method, a percent timer method, water meter, and a tracer? Anyways, if you could answer this question for me, I'd really appreciate it. Thanks a lot, Trace. And good luck on the show. I'm a very avid listener of your podcast, and I really appreciate all the tips and the tricks that you do present in your podcast. It's been really helpful for me, and it's helped me kind of push me in the direction of continuously improving my water treatment service. Anyway, this is Genipat. It's nice talking to you, and hope to see you soon.
Pat, thanks so much for asking your question. I remember when I said your name for the first time on the air, it was to congratulate you when you received your Certified Water Technologist designation. And I messed up your name on the air, and I know it's Genipat now, and you told me to just call you Pat, and I think that's how I've addressed you the last couple times that I've seen you. But something that you said with your question, when you were acknowledging that you really appreciate Scaling Up H2O, and thank you so much for saying that, but you said thank you for helping me get my Certified Water Technologist designation. Pat, you did all that heavy lifting yourself. I appreciate you including me in on that journey, but Guy, you did that all yourself. I appreciate you going after the highest designation in the industry on how you and I practice water. I think that means so much, and that proves to our client that, hey, you know what? We are really serious about what we do, and here's the proof for that. It's not just me saying that I'm serious about this. I've got an organization that's standing behind me, and it is legally defensible. How cool is that? Well, let's go ahead and get to your question. So I'm assuming that we're talking about cooling tower controllers. And with cooling tower controllers, if you look at them, we've got different ways to feed inhibitor. And a controller's functionality, it is going to normally measure conductivity. And when conductivity gets to a certain point, we will then open up a bleed valve. I think I've said on the show before, my father used to always say the solution to pollution is dilution. So what we do is we open up that bleed valve, and the concentrated water that we've concentrated up in that cooling tower then goes out the bleed, and the makeup line comes on. And of course, the makeup line is maybe 1/10 the concentration of what the concentrated water is. Of course, only pure water evaporates, leaving its solids behind, and every time we evaporate, those solids are left behind, so we concentrate whatever we're bringing in with the makeup water, or at least we hope we are, because if we're not, we're forming scale, and that's not how we want to scale up. We want to scale up on knowledge, not our systems. But Pat's question is, what are the different feed options there? And I've heard these different feed options with different names. So what I did is I broke them out into the 5 that I know are on every single controller. Now they might be called something a little bit different, but the short of it is we have bleed and feed, bleed after feed, percentage of on time, water meter feed, and then feeding on PTSA or some sort of tracing material. So we're going to talk about each one of those and why you would use those. I'm going to go ahead and put bleed and feed and bleed after feed together. So what that is simply bleed and feed is a function that whenever that bleed valve turns on, it is going to energize the pump for inhibitor along with it. So whenever that solenoid opens up, if it's on for 6 minutes, that pump is going to be on for 6 minutes. And then sometimes what people will do is they will put a percentage timer on that, and then that timer will actually count how long that's on for, and then you can set a percentage of how long you're going to allow the pump to pump for. Now, if you've never seen this is probably because you were not in water treatment in the 80s and early 90s, because that's how things were done. There were microprocessor controllers out then, but they are not available like they were today. And people are cheap. They want to spend money on so many things, but water treatment is not where they want to spend money unless they understand that that money that they spend is going to save them more money than they will ever spend on their water treatment program. And that's our challenge. We have to let our customers know that they do have to invest in water treatment. They do have to make sure that we have quality control equipment that does certain parameters that will ultimately pay them back tenfold. So bleed and feed is an older method of feed, and it's just simply whenever the solenoid bleed valve comes on, it's going to turn that pump on. Now, bleed after feed is kind of the same thing, but it is not going to feed, the inhibitor pump's not going to feed until after the bleed is shut off. And the theory behind this is whenever that bleed valve is on, you're wasting product. And I can't tell you how many older engineers have complained to me that we're not running a program properly because we are bleeding at the same time we are feeding. Well, folks, if you plumb the system properly, the product you're pumping in has a really long way to go around the system until it gets back to that bleed valve. So that's not a bad thing to do. Now, if you have it plumbed incorrectly and you're feeding 2 inches before you're bleeding, well, yeah, absolutely. You are going to be bleeding out all the product that you put in there. But make sure you do your survey properly. Our friend Blaine Nagel was on the show just a couple of weeks ago explaining how important it is to do a survey so you can plan the proper way to set up all your equipment. Do not assume that the last guy set it up properly. Do your own work. Make sure that you understand why things are feeding where they are, and you verify that that is the correct way for it to feed. So let's recap, because I've kind of been all over the map with little segues here. So bleed and feed is whenever we call for bleed, the pump for the inhibitor is going to come on. Whenever we are using bleed after feed, so whenever the bleed valve shuts off, that's when the pump is going to come on. Now, another way to feed is percentage of on time. Now, what that means is however long that cooling tower is on, it is then going to take a percentage of that time, and it's going to activate the inhibitor pump. Now, this is the way that I will feed if I have no other options. I don't feel that bleed and feed or bleed after feed is an appropriate way to feed a cooling tower. Now, if you have a 1975 controller out there and that's the only way you can do it, well, that's the only way you can do that. I want to get to one of my preferred methods in a second, but if we do not have the equipment to feed any other way, I will do calculations, and I share those calculations at the Association of Water Technologies technical training when I do math calculations, and we figure out how long the system is going to be on based on the data that we collect on the survey. We then set the controller up based on the pump size to come on for a particular amount of time when that cooling tower is on, and we try to get that to match up for what we figured out our daily chemical dosage is for that day. And we do that with percentage of on time. So let's say we want to turn the pump on for 30 seconds for every 5 minutes that the cooling tower is on. So what we're going to do, we're going to set the controller up to recognize feeding with a percentage of on time. And we're going to say every 5 minutes. Now we might have to put that into 300 seconds depending on how the controller is. And I'm going to go ahead and let you know that that's 300 seconds. And then we're going to say we want to feed 10% of that. Well, 10% of 300 seconds is 30 seconds. And every 5 minutes when that cooling tower is on, we're going to turn that pump on for 30 seconds. And then we would dial our pump in to the appropriate dose, whatever we want to get in every 30-second period. So that's percentage of on time. The way I really prefer feeding cooling towers is based on demand. And there's two ways to do that. There's how much water is coming into the system, and that is my favorite way to do that. If we lose water for any reason, our controller is going to know about it, and then it is going to pump the proper amount of product to replenish whatever was lost. So that means if we have a leak, if we are bleeding the system, however we lose water, we're going to see it via our controller, and the right amount of our inhibitor is going into the system. Now, if we're just using bleed and feed, well, let's say we have a leak in the cooling tower. That controller is never going to see concentrated up water because we're never concentrating the water up because of that leak. So it's possible we never feed product into that cooling tower. So water meters are one of my favorite ways to feed product. And water meters are just a great thing to have on a cooling tower. A lot of municipalities are giving credits for the amount of water that's being evaporated, which is about 90% of all the water that comes into the cooling tower, versus going down the drain. Now, here in Atlanta, we have very old infrastructure, and it costs more to get rid of the water that you bought than it did to buy it. So it really makes sense to take advantage of that credit. So we have water meters on the incoming water on the makeup, and we have meters on the bleed. Our customers then record those numbers, and they're able to get a credit. So check out if your municipality will allow that to happen, because I got to tell you, if you are talking to a customer and they don't know about that and you now tell them that they can save this money, it is way more money than you could ever charge them for your water treatment program. So that is something you definitely want to check out. And the only way you can do that is with water meters. So a water meter that you would buy would have some sort of contactor in it, and after so many gallons it sends a pulse back to the controller, and the controller is then set up via you to know every time it gets a pulse it's 10 gallons or 50 gallons or 100 gallons. And now you've done your math and you said for every so many gallons we're going to energize the pump relay to come on for a specific amount of time, and that's going to precisely treat all that new water that came in. So that is feeding based on demand, and that's one of my favorite ways to do that. Another way people are doing that is with a specific probe like PTSA. And people ask me all the time, what the heck does PTSA stand for? Or it's para-toluene sulfonic acid. I don't know if that's ever going to come in handy for you, but people ask me that all the time. Now you know what that means. But basically what PTSA is it is a fluorescent dye that we put in our products that these fluorometers, probes, that we put in our systems can read. So we can see that we have 100 parts per million as product when we read so much of the PTSA tracer in our product. Now, Nation, a lot of people have really gotten lazy when PTSA came out. And I'm all for shaving time off of servicing our accounts, but we have to understand the why behind everything that's going on in our accounts. And that means you have to test more than just the tracer, because that is all it is. It's just a tracer. It doesn't tell you anything about the active products you have in the system. A lot of people assume that if they have 100 parts per billion, and that's how it's measured. I know we are used to 100 parts per million. PTSA is measured in the parts per billion. So if we had 100 parts per billion of PTSA, people assume that they have an equivalent amount of whatever is in their product. Well, folks, that stuff gets used up. And it is imperative for us as water treaters to know what is getting used up to make sure that we have enough. If there's a lot of corrosion going on in the system and all of our inhibitor is going towards that, we might have a perfect amount of PTSA but not have any inhibitor in the system. So use that to tell you more about what's going on in the system, but please do not use PTSA to take away all the important things that we do need to know during each and every service. But of course, I'm talking about PTSA because controllers now will read how much PTSA is in a system, and then it will adjust based on whether it's high or low. But again, it does not know how much active product you have in your system. So don't just check PTSA. Don't check it on your meter and say, well, hey, it's matching the controller. Everything's good. I'm going to write that on the service report. By the way, don't ever write everything's good on a service report. Everything is not good. There's always something you can do there to make something a little bit better. And I always think if you write everything's good, that just simply means you're not looking hard enough. But all that to say, make sure you test what you're supposed to be testing for. So those are the 5 ways that you can feed inhibitor into a cooling tower system. So once again, bleed and feed, bleed after feed, percentage of on time, water meter feed, and then PTSA feed. Pat, I hope that answers your question. You asked when it was advantageous to use one over the other. Again, I really don't see any reason to ever use feeding based on bleed. There's just too many problems that can come up with that. The only time I would use it is if I went back in time to 1975 and that's the only thing that the controller would do. My preference is always to feed off of a water meter. If they don't have a water meter, and trust me, if they don't have a water meter, they're not going to have a PTSA fluorometer. Then I would go back to percentage of on time. I would set it up based on mathematical equations. And then from those mathematical equations, I would come back and check all my actives just to tweak the program to make sure everything that's supposed to be in the system is in the system in the right concentrations. Now, Pat, something you didn't ask, and I'm going to go ahead and answer it. So I'm asking my own questions now, are what are the different feeds that we can do with biocides? We were talking about inhibitors, but the other thing the controller does is biocides. And a lot of times we just think of biocide feeds as timers. And folks, I've seen Christmas tree timers plugged into an outlet and a pump plugged into that, and that was their biocide delivery system. Again, explain to the customer that they need to spend some money on their system and do some math for them. Show them how much product that they are wasting because they can't lock the bleed out when biocide feeds. Now, that might be confusing to some people because we said that wasn't important when we were talking about inhibitor. Well, inhibitor is going in all day long because we're constantly evaporating, we're constantly bleeding, we're constantly putting new water into the cooling tower. However, when it comes to biocides, the way we feed biocides is we have to know how many gallons we're treating for, then we dose the system with a specific parts per million of the biocidal product. And then we have to keep it at that concentration for a specific amount of time. We call that term contact time. So if we have a contact time of 4 hours and the product we're using has to be at 200 parts per million, we've got to get that product into the system as quickly as possible, but we want to lock out the bleed so it doesn't go below that 200 parts per million while it's staying in the system for that 4-hour period. And then afterwards, we're going to open up the bleed valve and then let it bleed as normal. So a controller, unlike a Christmas tree timer, will lock out the bleed while we have Biocide in the system. And folks, if you've never done the math on this, there is a tremendous amount of savings that you do not have to put Biocide in the system to simply flush down the drain. Because I mentioned in our example of Biocide here, we've got to get it up to 200 parts per million. Well, there's an equation called theoretical Biocide feed, and what that does, that allows us to calculate how much water we're going to bleed out over that 4-hour contact time period. So we have to overfeed the product past 200 parts per million, knowing that it's going to bleed out of the system, so we never fall below that 200 parts per million of the recommended dose during our contact time. So essentially, we're putting product in just to simply flush it down the drain. Folks, that's not good for the environment. That is not good for our customers' wallets. That is not good for our backs when we have to carry all that product to the mechanical room. So it is helping everybody involved when we get better technology to our customers. So when we talk about Biocide feed, it does work like a timer, and we have the ability to set up maybe a 28-day timer or a weekly timer or a daily timer. So depending on what you're feeding, you might want to feed that a couple of days a week. You might want to feed that every single day of the week, just depending on what the Biocide is. Well, controllers will allow you to do that. They will also allow you to pre-bleed the system before you start feeding that Biocide in. Now, why would you want to do that? Well, if we're going to lock out the bleed, we're continuing to evaporate, meaning those solids are continuing to concentrate. Well, since they're continuing to concentrate, we might go over what the top threshold is that we said we did not want the conductivity to go over. And if we exceed that, we could potentially scale the system. So there's a calculation for that. I actually invented this calculation to figure out how you can set up the controller for the precise amount of conductivity that you need to bleed out, and now you have a margin that you can build up concentration to without going over that top concentration level conductivity. So I think I had that on episode 3, if I recall. So if you go to my show notes page, I think that's on there because Tom Tenney took that calculation back to Lakewood Instruments, and they have, when you go into programming your Biocide feeds, they have the Blackmore method that comes up on the controller. Thank you, Tom. I love that. Every time I see your controller, I just think that's awesome. So you set it up for the timer, whether it's a 28-day, a weekly, or a daily. You tell it what time you want it to feed at and how long you want it to feed for. Then you're going to make it so you figure out how much conductivity you need to bleed out of the system before that pump starts pumping. And then there's a lockout time. And the lockout time in our example was 4 hours. So we're going to say we do not want the bleed to bleed for 4 hours. So this is how this is all going to come together. Say we're going to tell it to start doing this process at 6 a.m. on Wednesday. And we are now at 6 a.m. on Wednesday. It is going to start pre-bleeding the system. Let's say we're up at 1,000 and we told it to pre-bleed down to, 800. And those numbers are going to be different depending on how large your system is and how much it's evaporating. So let's assume we did all that information, we did all those calculations, and we know that we're going to bleed it down to 800. As soon as it gets down to 800, it's then going to start activating that pump, and we programmed it for a half an hour, let's say. So it's going to start pumping for a half an hour, and then after that half an hour goes by, the pump will turn off, and we are going to disable the bleed for a 4-hour period. The controller can do all of that. After that 4-hour period, it's just simply going to go back and operate as normal. And then whatever the next time is that we programmed in, it's going to do it all over again. Well, there's some other ways to feed biocides. And one of my favorite microbicides is sodium hypochlorite or bleach. Jim Lukanich does a great presentation on why bleach is such a good oxidizer in any system, and bleach just gets a bad rap. People say it doesn't work well in higher pHs. Well, it really depends on what you are trying to do. So if we were in a food process facility and we needed to clean an area in a couple of seconds, you're right. If we had high pH going on, bleach would not be the preferred solution to clean that area, because we need quick, free, available chlorine as much as we can get, because we don't have a lot of time to clean it. But a cooling tower, we have a tremendous amount of time that we can recirculate that in the system. So contact time is now really extended from before we had a couple of seconds on a food preparation surface. Now we have a tremendous amount of time in recirculating in the cooling tower. So when you feed sodium hypochlorite at a higher pH, you get an ion that Jim will explain that actually likes to penetrate the biofilm. So in his explanation, he thinks that's one of the best microbicides, see, I said it right, Jim, that you can use for that reason. So how do you feed that properly? Well, any oxidizer that you can use, and that might be chlorine, it might be bromine, it might be a mixture of the two, you need to know what the demand is. You might need more today than you will need tomorrow, and you have no idea what that is. So if you're feeding that based on a timer, so we're just simply going to put this many parts per million of sodium hypochlorite in the system every time that pump comes on, we are guessing. And sometimes we might be spot on, other days we're going to be low, other days we're going to be high. It's really hard to guess because the stuff growing in the system, it does not call ahead to let you know it's going to be there. It's just depending on what's going on that day. Maybe there's something going on across the street and there's a really heavy biological demand. Maybe they're cutting the grass that day and all the stuff that is around the cooling tower is now getting sucked in the cooling tower. So there is a probe called ORP, and I'll do a whole show committed to ORP because I think a lot of people misunderstand what ORP is, but here's the short of it. ORP stands for oxidation reduction potential. So how much of the juice that we're putting in is required to oxidize whatever the demand calls for. And there's a probe that measures that. It measures that in millivolts, and then we've got to figure out what's the millivolt reading that has the ideal amount of free chlorine in the system. And once we hone that in, then if we have a high demand day, it knows to feed more product. If we have a low demand day, it knows not to feed a lot of product. It is going to keep up with the demand so we don't have to guess. So that is my favorite way to feed an oxidizer, is based on demand. So I hope all of this information, Pat, helps you understand the controllers a little bit better. And I hope it gives you some information where you can go and talk with your customer and let them know how valuable that thing that they have no idea what it's doing on their wall, maybe it's been there for the last 40 years, that they need to look at that differently. And if it is not a modern controller that allows you, the water treater, to take advantage of all of the cool things that we talked about on this episode, then it is wasting their money. It is not being environmentally responsible, and it's making you work a lot harder and never getting the results that you could get if they bring that control into the modern era. So thank you so much for asking that question. I really appreciate it. And Nation, I appreciate it when you are asking me questions. So if you want to hear your name and you want to hear your voice on Scaling Up H2O, please go to scalinguph2o.com. Let me know what your question is. I will play it on the air. You can be the envy of all of your friends, and I will even send you a t-shirt when I play that on the air. Nation, I hope that you continue to learn throughout the week, and I will come at you next week on Scaling Up H2O.